This is the second video on graphing quadratic equations. And in this video, we notice that the equation that we'll see is a little bit different, has a different form compared to the first video. So the important things to point out are that the coefficient A is the same, so that still tells us if the parabola opens up or down, so we could still look at that coefficient. The different part is this HK, and in this case, HK gives us the vertex. So for this type of an equation, quadratic equation, written in this form, we could easily read off the vertex. We don't have to solve for it. So we'll do one example where we graph, and then the rest of the examples for the video, I will show you how to take your equation, complete the square, and put it in this form, and then we'll find all of the information we need in these steps, but we're not going to graph because that's the same as what we did before. So the second step is we want to find the y-intercept, and we have to set x equal to 0 and solve for y. So this is different from the first video. The y-intercept, in this case, we actually have to solve for it by just inputting 0 for x, and then you could solve for y. And then the x-intercepts are also different from the first video because we are going to use the square root property, which we learned earlier. And of course, the vertex is just going to be h comma k. You do have to be careful with the signs. So what you want to notice is that when you look or when you write your vertex, the x coordinate is the opposite sign. So if it says minus h, we just write h, where the y coordinate is the same sign. So when you look at your equation, you could have a plus or minus in these two places. It depends on the problem. For the x-coordinate, it's the opposite sign. The y-coordinate is the same sign as the equation. Let's take a look at the example where we have to graph. So we basically do the same thing as we did in the first video. We want to find the x and y intercepts, vertex, axis of symmetry, domain, and range in interval notation. So I started the graph here. And let's start by determining if the parabola opens up or down. So we have our equation, and in this case, the A coefficient, since I don't see a number there, the A coefficient is 1. You can put 1 here if you want. But it's positive, and so if it's positive, the parabola opens up. So that's the first thing. Next, I need to find the y-intercept by setting x equal to 0 and then solving for y. So x has to be 0. Here's the equation. If you input 0 for x, we're just left with negative 4 squared minus 4. You have to keep the parentheses there because this comes out to be positive 16 minus 4. And so we get that y is 12. And I can write my y-intercept as 0, 12. So that's a point. We could put that on the graph. We'll just put it there right now. So I have this point. Then we have to find the third step is to find the x-intercepts by setting y equal to 0. So find the x-intercepts by setting y equal to 0. Use the square root property. So y equal to 0. When you do this, you'll actually see that the equation looks exactly like what we have done before when we learned the square root property. So this type of an equation, the easiest way to solve it is to isolate the part that's squared by adding 4 to both sides. So this would be the fastest way to do it. And then once that's done, you use the square root property. You take the square root of both sides. You need to include plus or minus on this side right here on the left. When we take the square root of 4, we get plus or minus 2. Square root of the right side is x minus 4. And then, of course, we have to solve for x. Add 4 to both sides. And in this case, these are like terms. I can add and subtract. So one of the x-intercepts is going to be 6, 0. And the other x-intercept, so 4 plus 2 is 6. 4 minus 2 gives me 2, 0. So I have these x-intercepts. We could put those on the graph as well. So here is 2, 0. Okay, so 2, 0 and 6, 0. So I have those. And we also need to find the vertex. So remember, the vertex, we just look at this equation and we could figure out the vertex. So last step here, vertex. So it's an ordered pair. The x coordinate is the opposite sign here, so it's going to be 4. The y coordinate is the same sign, -4. We're going to graph that. Okay, so I have my points. I can graph the parabola. All right, we need to also find the axis of symmetry. Remember, the axis of symmetry is basically the vertical line that cuts the parabola in half. It always goes through the vertex. So we don't need to put this in the graph, but again, it just goes directly through the vertex. Axis of symmetry because the graph is symmetric on the right and left side if you cut it in half. And the equation of this vertical line will always be x is equal to 4. It's whatever the x coordinate is for your vertex. And we have to write x equals 4 instead of just 4 because this is a vertical line and we need to write the equation of the line. And then we need the domain and range. So for the domain, we focus on, just like we did before, focus on the x-axis. This graph will cover all the values on the x-axis because it continually goes up to the right and left. So it's all reals. And the range, we focus on the y-axis. So notice that the graph basically has a minimum here at the vertex. That's the minimum. So basically starts at -4 and goes all the way to infinity. And we need to include -4. So we have a bracket. And that is the first example. Let's take a look at the other examples, which we don't need to graph for those. You should be able to do the graph on your own. I'm just going to show you how to rewrite your equation by completing the square and then finding all of the values you need to graph. So all we want to do here is we would like to, it says to rewrite the equation in the form right here, which is the one we've been working with. Find the x and y intercepts, the vertex, and the axis of symmetry, and that's all we need to find. You can graph it on your own. So let me show you how to do this. We have completed the square before, so it's going to be the same idea, just a little bit different. One slight difference. So we want to start by completing the square here, and notice that this equation we cannot factor it, or we can't do anything to this equation except maybe use the quadratic formula. So we're going to complete the square, and this is how we're going to do it. Okay, so I write the first two terms. I need to leave a little bit of space because we're going to add and subtract. And you have to remember one thing. When you complete the square, the coefficient of x squared has to be 1. And in this case, it is 1, so that's good. The formula for completing the square that we learned was you take your b value, divide it by 2, and square it. So the formula was basically b over 2 squared. That was the formula. So you do need to make sure you know that, memorize it. In this case, our b value is -10. Okay, so far it's the same as what we did before. Use the same formula, you get 25. Before, what we did is we added 25 to both sides of the equation. But I do not want to add 25 to both sides of the equation because then I would get y plus 25 here. And I'm trying to get this equation to look like this. So I don't want to add anything to my y value because then it's not going to look like this. So equivalent to adding 25 on this side is to subtract 25. So we can add 25 and also subtract 25. So this 25 before was added on this side. But I don't want to do that because I need to just have y here. You always add first, subtract second. So what's going to happen is that these three terms correspond to the part that's squared, and these two correspond to the k term. So we need to factor these. Make sure you understand that you need to write plus first, minus second. Don't flip it around because then you won't be able to factor. And then just combine those, we get -24. And our equation is now written in this form where you could easily get your vertex. Okay, so basically you add and subtract on the same side, factor, combine these two terms, and then we have our equation and it's in this form. So now let's find the x and y intercepts. By the way, this parabola opens up. But we want the x-intercept, or let's do the y-intercept first. You can get the y-intercept by substituting 0 for x, but since I have this equation here, if you go back to the first video, this number, 1, that's your y-intercept, so we could use what we learned before. So that's my y-intercept. You'll get the same answer if you plug in 0 here. Now we want the x-intercepts, and we're going to find them the same way. We're going to basically substitute 0 for y and use the square root property. I have to take the square root of both sides. I need to include plus or minus. Square root of 24, when you take the square root and simplify that, that's going to come out to plus or minus 2 square root of 6 after you simplify. And then I need to add 5 to both sides, basically just solve for x. Okay, these are my two x-intercepts. So we want to write these as ordered pairs. So one of them is 5 plus 2 square root of 6 comma 0. And the other one is 5 minus 2 square root of 6 comma 0. So I have that. How are you supposed to graph these? Well, you basically just use your calculator to estimate the location of these 2 points, and then just put that on your graph. And the next thing we want to do is find the vertex. Again, that's really quick. You look at your equation. So this is what I have here. it's going to be positive 5, comma, negative 24. That's the vertex. And the axis of symmetry, we get that from the vertex. Remember, it's the vertical line that goes through your parabola, cuts it in half. So it goes through the vertex. It's going to be x is equal to 5. It's always the x coordinate. And that's it. So the other example is a little bit different because we will not have 1 as our coefficient here. We're going to have another number that's not 1. So we have to do an extra step. So for this example, since we don't have 1 here, what you need to do is you need to factor out whatever this number is, but you only factor it from the first 2 terms. So we need to factor out negative 3 from the first 2 terms. I do not care about negative 12. This number is going to stay to the side because that is going to be part. So negative 12 will be part of the k value. So we got to be careful here. There's a few extra steps. We have to be careful with those steps. So factor out negative 3. I do not factor out x. I only factor out negative 3. I know you could take out an x, but we're not going to do that. So negative 3, and then we're going to be left with x squared minus, because I took out a negative 3, 4x. I have to leave some space, and then minus 12. So now our b value is negative 4. So we need to calculate b over 2 squared. And that's, in this case, will be negative 4 over 2 squared. That's going to be negative 2 squared. So we are going to, same thing, add and subtract. But notice that you're adding and subtracting inside these parentheses. So got to be a little bit careful with this. It's plus first minus second. These 3 terms are the 3 terms we use to factor. That negative 4 is part of your, this negative 4 is part of your k value, but I can't just take this out of the parentheses. We have to multiply it with negative 3 first. So this negative 4 needs to be outside the parentheses, so we have to multiply with negative 3. So this is what we're going to get. I'm also going to factor. Okay, so now negative 3 times negative 4 is positive 12. I factored the first 3 terms. This will give me 0. You can write plus 0, or you could just not write it at all. And let's calculate what we need to find. Notice that the a value here is negative 3. This tells me the parabola will open down if we were to graph it. So let's see, the y-intercept you get by substituting 0 for x and solving for y. We could also just quickly get it from here. It's going to be 0, negative 12. X-intercepts, plug in 0 for y, for y here. I'm going to divide by negative 3 on both sides. If you divide by negative 3, 0 over negative 3 is 0. So I'm really just left with this. When you square root both sides, square root of 0 is 0. So we don't write plus or minus 0 because 0 is neither positive or negative. We just write 0 when we take the square root, and x minus 2. So this says x is equal to 2. There's only one x-intercept, which is interesting because usually we have 2. But let me show you what's going to happen here. So that's the ordered pair. And now we want to write out the vertex. Okay, so the vertex, this is H, this is K, right? So H is going to be 2, K is going to be 0. This is interesting because the x-intercept and the vertex are the same point. Sometimes that can happen. It just means, just a quick picture here, if I were to, this parabola opens down, so basically it's going to look like that. Okay, so the vertex is on the x-axis. And that's exactly where the x-intercept is. So we can have that. Let's see, the next thing we want is the axis of symmetry. And in this case, it's just the vertical line that cuts your parabola in half. The equation of a vertical line would be x equals 2, the x value. And that is the end of this video.